Okay. Start. Okay. With respect to the tools, we have already covered GitLab, so GitLab, Terraform, little bit into AWS, because we already created resources in AWS like EC2 instances and little bit of S3 buckets. So now we are currently moving on to looking at Docker. So we have already seen what is Docker. It is basically a containerization tool, and orchestration tool is Kubernetes. I have already explained running a Docker container on a VM. There is no clarity how many containers are running, what is the status of the container. So it is very difficult to identify and fix the container running containers. That's why we need an orchestration tool that is nothing but Kubernetes. Before looking at Kubernetes, we'll be looking at how ECS works, how containers are created, what containers contain, what are the different things we should consider while creating the containers. Okay, any questions on this?
No, Shankar.
Sure, I'm moving on. Anyone quickly answer me, what is the difference between access key, secret key, and public key, private key? Maybe because access key.
This key use facts. I am
I'm sorry.
using
Yeah, IAM user.
access. Yeah, I am. It is generated through the IAM user. Like it's generally used to configure the AWS AWS application with Terraform script, whatever we write, like a
Right,
console.
exactly.
Yeah.
Right. So basically, for authentication purpose, especially AWS account related, if you want to do anything on the AWS account, you need to have access key and secret key. Anybody has doubts on this? Because it should be very clear. What is the purpose of private key and public key?
It's just to connect to the server.
Private key is like a password.
Good.
So public key like a username. So we should connect with both the combination.
Exactly. Cool. So username is always, the public key is always on the remote machine. Private key on the local machine. This is private key. This is public key. So this is basically server to server authentication. Basically one local server to the remote server. It could be local server to EC2 instance or local server to GitLab server. So how do we connect to a GitLab server? Any anything you are able to recall? How do we connect securely to GitLab account?
With username and password, and from the Git bash we need have that access key registered in
Uh,
the GitLab.
Not access key, the public key.
Public key, sorry, public.
Yeah, public key must be copied into the GitLab account settings. Okay. So if this one is clear to all the people, you are actually one step ahead for your interview. Basically, if you are attending less than 2.5 years experience interviews, you are good to go. Okay, moving on. So I basically wanted to look at the darker one. I don't know whether I have the darker one here. Okay, here it is. So we already looked at why virtual machine, what are the disadvantages with virtual machine. See, if you want to run multiple operating systems on a single physical machine or a single hardware, virtual machine is the way to do it. But the problem is you are not using effectively the resources. It is same like a physical machine. Everything you need to package it here one by one. All the packages, kernel, dependencies, libraries, so many things that you need to do it on the VM. VM becomes heavy. Heavy means it is very difficult to port it or copy it to a different location, because in GBs, the data that you want to copy from one place to another place, it takes time. It's time consuming. So it becomes a hurdle or hassle for people to do things. That's why we are moving to Docker. Docker means it's another container system, popular container system. So we basically need to run a particular service on a machine so that you make the server accessible to people. So we already spoke about what is server, what is services, how do you make the service accessible to people. That is through firewall rules or security groups. And the way to run the service is like systemctl start or service start. You guys have any questions on this? How to start a service, say HTTPD service?
Yeah, system.
Yeah,
Systemctl.
systemctl command or a service command. Before Red Hat Enterprise Linux 8, we used to do a service restart, service start, service status like that. But after RHEL 8, it is replaced with the systemctl commands. Okay. The whole and sole purpose of running a machine or starting a machine is to run a service, make the service accessible to outside people. That is the whole and sole purpose of running an application or making the application accessible to people. Instead of creating a full-fledged VM, we are creating a simple container, which is a lightweight operating system, portable to everywhere, and it is running in an isolated environment. When I say isolated environment, it is nothing but you are running multiple containers of the same on the single machine, where only the port number is different. This is running on port 1, this is running on port 2. It is up to the customer what port he wants to access. So at the same time, on the single machine, you can have two different services running using container system, and you can make it more efficient. You can run multiple versions of the same application. The only disadvantage of having a Docker, having a container in your VM, is it is ephemeral in nature. That means there is nobody, no way you can actually track what is going on with the container, because only some set of libraries, some set of packages, some set of memory and CPU, you are trying to use it from the system, physical machine. From the physical machine, it may go out of memory, disk, or any other problem. So that's why we are kind of in a situation where we need to manage the running containers. That's where Kubernetes come into picture. Kubernetes is one of the popular container management system, container operating system. Just a second. So, any questions on the introduction to Kubernetes? So we are just saying only why Kubernetes, but we are not saying what is Kubernetes yet. Okay. Okay. So for container to be running, we need to run the container and we need to make sure everything is packaged inside a container. For packaging, you need to create an image out of it. It is something similar to the AMI. If I say Docker image, it is something similar to AMI. Or it is something similar to a snapshot. How many of you know how to create a snapshot from EC2?
So from the S3,
No. If you go to AWS console, go to EC2 section. If you go to a particular instance, running instance, you can select that instance and create a snapshot of it. That means whatever you have already created, whatever is already running, it will be taken as a snapshot. When the snapshot is created, and then you create a new machine from this snapshot using this snapshot, this EC2 instance will contain whatever was running before. Exactly the same thing it will contain. It is a purpose of creating a copy of whatever is running. So that is one of the popular thing or most important thing in terms of virtual machine or in terms of running a cloud instance. Any doubts?
And sir, is it for backup purpose or this snapshot will be public accessible?
See, publicly accessible or it is backup, it's all up to the team or up to the individuals. Say, for example, you are creating one EC2 instance, right? And you are adding so many packages and you are installing some binaries, some applications, and you really worked very hard to create that application running, right? What do? Would you create the same thing again and again whenever you want to create an EC2 instance? No, right? What you would do is you would package everything and say, create a snapshot.
like by using disaster recovery, right?
So disaster recovery does not come into picture. See, disaster recovery is totally different.
Yeah,
See, you
based
can
on the
think it is
snapshot, we can fetch that old servers, right? In the
see, you can say that it is a backup. You cannot say disaster
oh,
recovery.
okay, fine.
So DR basically means when there is a disruption in the running services. See, it is just like another solution or another backup that you are trying to create.
Okay, fine.
For example, the second day, third day, then again you are adding some more packages. What do? You create another snapshot and then delete this snapshot. You keep it like this because you want to really save your work. That is the purpose of creating a snapshot. So similarly, on the Docker side also, there is a base image, something similar to the AMI. And then on top of it, we write a Docker file. In the Docker file, we add few things and then we create another Docker image out of it. That is something like a snapshot. So that image can be pushed to Docker Hub or Docker Registry or ECR, Elastic Container Registry in AWS. So that is the whole and sole purpose of creating an image and pushing that image so that it can be sometimes deployed into your EC2 instance or ECS cluster. Deploy means running the container. Running the container is nothing but deployment. Okay, if you could see this, right, whatever I explained is already there in this page. Docker file is all about the instructions how to create a Docker image. Docker image is the actual build that is available for deployment. Container is the one which is deployed version of the running container. Docker Hub is where your image is stored. Docker volume is all about how to mount a volume so that system volume can be mounted to the application that is running in container. We'll talk more about it. If you'd have seen my video before, it would be easy for you to just catch up whatever I'm explaining. Okay. We have another 8 minutes to go. So like I told you before, the traditional way of running a service is like systemctl or service. And then to check if the service is running, we can use ps command to check if the service is running. And if you want to stop the process, kill the process, you can use kill -9, that is forceful kill. Like that, I mean, with respect to the service, you can do it like this. When it comes to Docker, it is a Docker ps, Docker ps, Docker stop, Docker start, Docker logs. So like that, there are so many different options. That is very much similar to whatever you do in a traditional services. Same thing. I mean, but it is just another version of Docker. So one of the reasons why we didn't want to go with virtual machine is we need to pull all the dependencies every time. That becomes a big hassle, difficult to scale. That means it is difficult to add virtual machines. And once you add a virtual machine, you need to also create that application over there. That is also another problem. So you need to create an exact application on the same on the other instance. So it becomes a little too much for you, little overhead for you. That is the reason why people moved out of virtual machines, moved to Docker containers and maybe microservices architecture. Okay. Inefficient resource utilization in the VM, slow deployments. It is inconsistent across environments because one virtual machine you create, another virtual machine is created by some other person. Even though initially it is same, but over a period of time, people install few packages, run few other systems, few other packages, few other softwares, applications, and then make it probably one is say version 1, this one is like version 2. Both are not equivalent. So it will create problems over a period of time. That's why we say it as inconsistency across environments. Whereas when it comes to container, your container remains same irrespective of whatever machine, whatever VM in which you are running. So consistency is maintained the maximum with the container based deployments. I'll skip these things. It's a repetition. This also, most of the things we already covered. We require a full OS on the virtual machine, whereas here we are sharing the host operating system and host kernel. It boots entire OS whenever it requires a restart, but it's a lightweight. It spins up the container within few seconds, not even in minutes. Okay. I think with respect to Docker, the slide is over. Any doubts, any questions before we take a break and then come back?
So it's all about Linux commands we use to right in the Docker.
Yeah, basically kind of commands like ls, pwd, cp. All of these commands are very common inside your Docker containers because we create Docker containers basically on a Linux OS, mostly Ubuntu based or any of the lightweight Linux operating system, we create the image. So anything that you want to do that requires basic Linux commands, similar to what you did for the GitLab CI. You remember for the GitLab, we created we created commands script.
Bash.
Inside the script section, we'll say Terraform init, Terraform plan, Terraform apply. So basically everything is like a command. So instead of commands, we are just saying script. That's all.
Yeah.
Okay, I'll disconnect the call. I will join after 5 minutes.